Day 3. So we're continuing on with probability. So just like before, I've written some notes out for you guys. So I want you to just go ahead and copy those down. So if you need to pause and take a minute, go ahead and do that. So for today's lesson, we're going to be talking about how probability, if we're going to solve for a probability today, we're going to take our successes over our totals. So you're going to see that a lot in what we're covering today. So go ahead and write that out. And then I have just kind of an example of different events. So we're going to use multiplication. So just like what we have here. So if you have a coin toss and you are going to toss that coin 3 times, what's the probability that you're going to get heads? So you have 1 shot out of 2 the first time, and then again the second time it's the same, 1 out of 2, and the third is 1 out of 2. So you would just multiply those together, and that would give you 1 over 8. So just keep in mind for that, we're going to talk a little bit more about that as well. Probability, your answer should always come out to be between 0 and 1. If it does not come out in that range, you need to go back and check your work again. It shouldn't be less than 0 or greater than 1. And there's 2 different types of probability that we're going to cover. Independent, and that means every time we start, we're going to have, every time it starts new. So what we did previously does not impact what we're doing moving forward. Whereas dependent is the opposite. The first outcome of our probability that we've solved for is going to affect our future outcome. So if you need to, pause the video and just go ahead and write those down, and we'll kind of talk a little bit more about those as we get into this. So the first problem we have says find the probability of rolling a 6 on one die and a 6 on the other. So you guys are going to get a sheet just like this one here. So I'm going to use this right now, and you guys need to make sure you hang on to this because we're going to use this throughout this whole unit. So it says find the probability of rolling a 6 on one die and a 6 on another die. So you're going to take a look at all of this. This is all of the possibilities that we have on this sheet here. So for number 1, we're going to just write down our 2 little boxes. And what's the probability of rolling our first dice and second dice? So we're going to put, or die. We're going to write those out. So the probability of rolling a 6, you have 1 chance out of 6 on the first roll because only one side has 6. And the same again if you re-roll that same die. So if you roll twice, the probability of rolling a 6 on one die and then a 6 again on the second time is going to be when you multiply these 2 together. So you're going to get 1 over 36. So that's the probability for that. So number 2 says find the probability of tossing a heads, then a heads, and then a tails when tossing a coin 3 times. So kind of like the example problem that we did. So we have a heads, and a tails. So that means we have 3 opportunities. And we only have 2 sides. So remember, up at the top we wrote our total is going to be on the bottom. So we only have 2 sides for our coin. So we have a total of 2 choices, and the probability of it going to heads the first time, and then again it's independent, so you're going to retoss again. So that's a 1, and then tails the last time. So just like what we did up in the practice problem, so this is our first toss, this is our second toss, and here's our third right here. So after you multiply those together, your probability is 1 over 8. So we're going to flip back to that sheet you have with the die on there, and it says 2 die are rolled, 1 white, 1 yellow. So find the probability of the following events. So I'm going to label, I know this is like a black and white copy here, so I'm just going to label. These are going to be my white die, and these right here are going to be my yellow. So it says for the first one, the white die shows a 6, and the sum is greater than 9. So you're going to look at your white, or you're going to look at your sheet right here, and you're going to look for all of the places you have a 6 for your white. So we have 1s, 2s, 3s, 4s, 5s, 6s. So here we have a 6 for our white. Let me scroll up so you guys can see that. So 6 for our white here, and then it also says, and the sum is greater than 9. So 6 plus 1, that does not equal anything greater than 9. 6 plus 2, that's not it either. 6 plus 3 is 9, but the equation says greater than 9. So we have 6 plus 4, 6 plus 5, and 6 plus 6. So these 3 options right here. So what we're going to do is we're going to make our little box. Remember, our successes. So how many times are we going to meet that goal? That's 3 times. But out of our total, so out of our total sheet, we have 36 options. So it's going to be 3 over 36. So we're going to put 3 over 36, and we'll reduce that down. That comes out to be 1 over 12. Same thing again. Let's do that with B. So we're going to look at our die sheet again here. So we have our white and our yellow. So it says our yellow die shows an even number, and the sum is 5. So here's all of our yellows. So we're going to look at our even numbers. So these here are possibilities. These are yellow evens, and these are all yellow evens. And it says the sum is 5. So you can kind of go through and look at all of those. That would be a possibility. So we have 2 and 1. The sum is not 5. So we're going to kind of go through and we'll count up all of the ones where the sum is 5. So we have 1 here, and we'll keep going throughout that. And we end up with only 2 real options there. So we're going to have 2 over, again, how many options were our total? And that's 36. So we have 2 over 36, and that's going to reduce down to 1 over 18. So make sure you hang on to that die sheet. You also have the sheet with the cards as well. So let's look at number 4. Number 4 is a little bit different. We're not going to use either of those sheets on that. So we have the table shows domestic migration from 1995 to 2000, and a person is randomly selected. So we're going to find each probability. So we're going to read and use the information that's given to us exactly. So A says we are looking for probability where the emigrant is from the West. So we're going to take a look at our table here, and we have our emigrant, so we know that we have to start there, and it's from the West. So we have 2,654. Those are how many successes we have. Remember, we talked about that. What's our total, though, for this? So we're going to take our total from all of our emigrants, which is 11,656. So we're going to do that over, and then we're just going to plug that into our calculator. So you're going to divide 2,654 by that, and you're going to end up with 0.228 there. So B is a little bit different. It says someone selected from the South is an immigrant. So we're looking in a different spot for these. So take a look at the table, see if you can figure out what we're looking at. So we know it's someone from the South who is an immigrant. So we have 5,042. That's how many people meet the criteria. And then the total is all of our people from the South here. So that's 5,042, and then we're going to add that to 3,243. So we'll put that over 8,285. And our total, after you divide that and put it in your calculator, is going to be 0.609. So again, remember, all of those need to be between 0 and 1, which both of those are so far. And the last one says, see that someone selected. So this is going to be from all. This one's worded a little bit differently, but this is going to be from all of our group options and is an immigrant from the Midwest. So we're going to look up at our chart here, and we're going to find our immigrants from the Midwest, which are 2,951. So that's how many fit our criteria, and it's out of the total number of all of the people that we have. So that's going to be over 23,311. So go ahead and add up those numbers if that's going to help you if you're a little confused. After we plug that into our calculator, we're going to end up with 0.127 for our answer there. So if you want to go back and go over those again, that was pretty quick, but we'll talk a lot more about that in class as well if you have questions. So now we're going to move on to our cards here. So our problem here for number 5 says 2 cards are drawn from a deck of 52. So find the probability. So number 5 says we're selecting 2 hearts when the first card is replaced. So we know we have 2 options. But this is back when we talked about in our notes where we have dependent and independent. So this one is going to be independent because we're replacing our card. So we're selecting 2 hearts, but we're replacing our card. So out of the total number of cards we have, we have 52 cards the first time, and we also are going to have 52 cards the second time because we're replacing that card once we've drawn it. So you can take a look at your cards. You'll have this sheet here, and you'll be able to count them all out. But I'll tell you, you have 52 total cards, and you have 4 suits. So in each suit, you're going to end up with 13 cards in each suit. So if it's asking you to select 2 hearts, it's going to be out of 13. And again, you're replacing it, so it's going to be the same number again. So 13 over 52 times 13 over 52. That total comes out to be 169 over 2704. And that'll reduce down to 1/16. 6 is a little bit different because we are selecting 2 hearts when the first card is not replaced. So I'm going to draw out my 2 boxes again. So I know I have 52 cards to start with the first time, but this one says the first card is not replaced. So once I've removed a card, I don't put that back, so that means I'm going to have only 51 the second time. So same thing for selecting 2 hearts. I start with 13 as my option. I can have up to 13 hearts, but if that was a heart that I chose, I may only have 12 left. So this one looks a little bit different. This one was dependent because the first outcome affected the second outcome. So we'll multiply there, and we'll reduce down to 1/17. And then the last one says a queen is drawn, not replaced, and then a king is drawn. So we're going to start again here. We know we have 52 cards to start from, but the key word here is it's telling us that it's not replaced. So that little phrase tells us that we start with 52, and after our first card is drawn, we're not replacing it, so we only have 51. So we only have 4 queens. So again, you can reference your sheet here. You're going to go through and you are going to determine how many face cards that you have and of all of these, and you're going to only end up with 4 of each. So we have 4 queens to choose from. So we're going to put a 4 there. So we have 4 queens out of the 52 choices. So once we removed one, we only have 51 choices left. However, it says now we're going to draw a king. So all of our kings have the potential to still be in there, so that number is going to be 4 as well. We'll multiply these, and we end up with 4 over 663 as our final answer. And that's it for today, guys.